Welcome back. How was it? Did you get it? Was it a tough question? Don't get too disappointed if you weren't able to get the answer. These questions are meant to be tough, to stretch your mind. If they were too simple, then you wouldn't be learning anything. Let's start off with the naive approach. That is, the approach that first comes to mind. For me, the very first one is going to be a nested for loop. Let's have a function. I'm going to call it first recurring character. It's going to receive an input. And because we've already talked about it, I'm not going to do any input validation. We can just assume that we're always going to get some sort of a numbered array. In here, I'm going to loop again. And oh boy, I've done this so many times by now. I hope you're getting sick and tired of just looping through arrays. But hey, now at least we are masters of loops. I plus plus. So in here, in the first loop, we're going to grab the first item in the array. And let's just call this function so we have it here nice and easy and gives us a nice visual. So I'm going to loop through the first item, then the fifth, or the second, the third, the fourth, and keeps going. I want to grab this item and then do another loop and check 2 versus 5, 2 versus 1, 2 versus 2, and then say, that's the one. If it doesn't find anything, it's going to go to the next 5 and then compare 5 to 1, 1 to 2, 2 to 3, and so on. So once again, I'm just going to copy and paste this time because we have done a lot of for loops. And simply change the variable to be j. We're going to start at 1 because we don't want to compare 2 to 2. We want to compare 2 to 5 to start off. So we're just skipping a loop, which will help us out. I'm going to say j here and j++. Now, some of you may have been caught here because if we have it the way it is right now and you console log this loop, you'll see that it won't work properly. Because every time this shifts, the outer for loop shifts from, let's say, 0 to next one, the 1 index, j is going to be reset to 1. So 5 is going to get compared to 5, and the function is going to assume, 5's the reoccurring character. So a little trick here is to do I plus 1. That is, we always go 1 to the right of where I is, the first index is. So if we're looping, and we're at here, the subloop, the nested loop, is going to look at I plus 1. So it's going to compare 2 to 3, 2 to 5, 2 to I, because, well, we've already compared 2 to 2, 5 to 1, 5 to 2, 1 to 2 in previous loops. All right, we've done that. In here, we can simply do an if statement saying input I, does that equal input j? Does 2 equals to 5? Does 2 equal to 1? Does 2 equal to 2? If that equals, then just simply return input I. Otherwise, if we do all this work and nothing happens, we can just return undefined. Let's see if that works. I'm going to run it, and I get 2. Awesome. What if I change this to 1? If I run this, I get 1. Perfect. What if I do just a single item in an array? I get undefined. If I do an empty array, I get undefined. That's good. What if I do 1, 1 or 1, 1? I get 1. That's great. If I do 1, 2, I get undefined. Awesome. This looks to be working. Nice and simple. But as you can see here, we're not being very efficient. We have nested loops, which should trigger, oh, this is O of n squared. And although technically we're actually always looping a little bit more efficient because of I plus I, we're not looping twice over the entire array. In the end, when you remove the constants and simplify things, it's still going to be O of n squared. So how can we solve this using hash tables? Well, let's create a new function. We'll call this function by the same name, this time number 2, version 2. It's going to receive an input. And let's change our test case to have the same thing like we did previously. What can we do here? Well, let's use a hash table or an object to do something interesting. That is to add these, all of these as we iterate one by one, so loop through all the items, add them to a hash table, and while we're doing that, we can check to see if the property already exists or the key already exists. We add 2 to the hash table, then 5 to the hash table, then 1 to the hash table, and when we try to add 2, we can trigger a warning saying, we already have 2 as the key. So using that logic, let's see how we can implement it. I'm going to create a map. We'll just call it a hash map for now, because the keys are going to be unique. It's not going to let any duplicate keys. And we can simply do our loops. And in this loop, all we're going to do is say if map, and we can check in this map if it's empty. Now the first check in here, I want to say if the property or if the key already exists, I want to just return the item because we don't need to do any more work. As soon as we find a key that already exists in our hash table, stop all the looping and just return. In this case, we want to return 2. So at index 0, 1, 2, 3, it's going to return and say 2 because, well, this key already exists. So the way we do that in the if check is to simply say if input I, because remember, this is going to equal to 2 when we loop through it. If that exists, then return. Otherwise, we will just add it to our map. So input I is going to equal, and the value can be anything. We'll just leave it at I, which is the index. So 2 is going to equal 0, 5 is going to equal 1, 1 is going to have 2. Let's just console log here to see what is happening. But I want to also return undefined at the end in case none of this happens, in case there is no match. So at the end of the for loop, we'll just console.log map and see what we have. I'm going to run and I get 5. And there's no log. What just happened here? Well, if we console log up here instead and take a look at what this is giving us and run, I get undefined, undefined, undefined 0, undefined 1. What does that mean? Well, remember, we're looping through here and we're saying, hey, does 2 exist? Does input 0, which is 2, exist as a key. So it's simply saying map.to. Does it exist? And because that doesn't exist, we get undefined. And it's going to go to next. Hey, does 5 exist? No, it doesn't. Hey, does 1 exist? No, it doesn't. Hey, does 2 exist? And as soon as it checks 2 again, map 2, it's going to say, I already have it. It's at index of 0. So this is working. However, because when this gets to 0, the way JavaScript works, it puts 0 here, but in an if statement, 0 is what we call falsy in JavaScript. And that has to do with type coercion in JavaScript, something that a lot of people get annoyed about with the language. So what we would need to do is to make sure that we specify that we want this to not equal undefined. So as soon as it doesn't equal undefined, I want you to return this item. Now, if we run this, we get 2, which is great. If we console.log the map and run this, and let's add it at the bottom here so we see the actual iteration that's happening. We see that it adds 2 at index of 0, then 2 at index of 0 and 5 index of 1, so on and so forth until it stops after the third loop because it encounters 2 again. It's going to check and say, ooh, 2 already exists, just return it. How cool is that? We just made this entire thing with just one loop that is way faster than our first version using hash tables. How cool is that? For me, doing things like this and seeing the power of how learning about Big O and hash tables has improved our coding ability just gets me really, really excited. And I hope this gets you excited as well. We made this function have a time complexity of O of n. We've improved it with one downside. We've increased the memory, the space complexity by O of n because we're creating a new object in this function that needs to keep track of all the items in the array. And in the worst case, when there is no match, it's going to go through the entire item list of the array and hold that information in the map. So we're also going to have, unlike this version where we didn't create any space complexity, we just had space complexity of 1, we now have a little bit more. But in turn, we have a faster function. Very, very cool. Now to finish off, I want to give you one last challenge. You see, looking at these two implementations, what happens if we have something like this? What do you think the first recurring character is? If I run this, I get 5 because, well, 5 occurs sooner than 2 because of the way we implemented the second function. However, if I go to the first version of our function and run this, I get 2. Why is that? Well, if we go to the very first part of our function, we see that the way we are doing things is we are going one by one in a different way. We're saying grab 2 and then compare 2 with 5, then 2, then 3, then 5, then 1, and 2, 4. And then move over to 5, then 5, and 5, and 2. And so on and so forth. And because of the way we have that implemented, it's going to detect 2 and 2 because the outer loop has an index of 0 and has 2 as it's going through the loop before it compares 5 with 5. Versus our second version with a hash table where we had all these items and we were able to compare them once we grabbed all of them. And that's another powerful thing when you think about arrays and hash tables and how you're able to compare things. And based on what the interviewer asked, you might have a wrong answer. Maybe they want you to detect 5 and 5 before you detect 2 and 2. So my bonus question to you, if you have time and a bit of a challenge, is to convert this function, if you want, into something that matches the answer to this, that is to detect 5 and 5. How would you go about doing that? You're most likely going to have to do something interesting here. So good luck with that. Talk to other people on Discord in our community and see if you can figure it out. And I'll post some creative solutions to that problem as students submit them to see how other people have implemented this. But for now, I think we deserve a break. I'll see you in the next one. Bye-bye.